This video is on quadratic equations, and first of all, let's talk about quadratic functions. Set it equal to 0 on the right-hand side, so 2x squared minus 1 equals 0. So if I do that, I now have a quadratic equation. I can do it with the red one too. I have x squared plus 2x minus 1 equals 0. Notice that my 0 is on the right-hand side. You want to make sure of that on your quadratic, when you're changing quadratic functions to quadratic equations. So x squared plus 4 equals 0. The reason you want to set them equal to 0 is we want to solve them and find out where it crosses the x-axis. So let's kind of talk about what they look like. So equation-wise, they're going to be in this form up here. You can see that there's going to be a number. The a, b, and c are numbers. So this is a number, number, number. So it has to have an x squared and an x and a number. And also, I should put in there that, this is making it messy, sorry about this, a cannot equal 0, so it has to have an x squared. B can equal 0, but a can't. So if you take a look at this first one, if I wrote this in that form, I have 2x squared plus 0x minus 1. Since I can write this in a quadratic equation format where this is the a, so the a is 2, the b is 0, and the c is negative 1. If I can do that, then that's a guarantee that it is a quadratic function. So the red one, the second one, if you take a look at that, that's already in that format. What do you think a would be? Well, there's no number there, so a must be 1 because we have 1x squared. B is equal to 2 because you have 2x. And c is equal to negative 1 because you have a negative 1 there. If I take a look at the blue equation, a is equal to 1, b is equal to 0 because there is no x, and then c is equal to 4. And so that's a guarantee that all three of these are quadratic equations. Now the other way to make sure they're quadratic equations is you can solve them, and they should make like a smiley face or a sad face. So let me show you what I mean by that. So I just quickly drew some some coordinate systems. So a quadratic equation can look like this. It can look like this. It can look like this. And it can look like this. So it can float up and down. It can even float like you could have one look like this too, way over here. So it can float right and left, up, down, but it's always a smiley or a frown. So when we solve quadratic equations, we're looking for the point where they cross the x-axis. So like that one crosses twice. This one doesn't cross, the first one doesn't cross the x-axis. This one crosses x-axis twice. This one crosses x-axis twice. Let me draw another one that just crosses the x-axis once. Okay, so those are the solutions we're looking for. When it crosses the x-axis, let's say this was a real graph right here. Let me change colors so you know what I'm talking about. Let me go to purple. Let's say this was the real graph right here on this one. The solution would be where it crosses x-axis. So this crosses at the point 3, 0, and it crosses at the point negative 4, 0. Notice that the y is always 0 where it crosses the x. So that's why we set those all equal to 0. Because if we can find out when y equals 0 and what x is at that point, then we'll know the solutions. So quadratics, the biggest confusion at the beginning is, what does it mean by solving a quadratic? What it means is finding where it crosses the x-axis, finding out what x is when y is 0. So here's just a summary of that. So when you want to find a solution, You're looking for where it crosses the x-axis. You could graph them, but you're not going to want to graph every single one. We're going to talk about it because you need to know how to graph them to find the solution, and you need to know how to find the solution algebraically. So they call it symbolically. Okay, so it's where it crosses the x-axis. At that point, the y value will always be 0. That's why you set it all to 0. If you have x squared plus 2x minus 4, you set it equal to 0. Because remember, the y is really sitting here, right? So I want to know what happens when y equals 0. So I put a 0 in there. So let's talk about what solutions look like and how many types of solutions there are. So there are 3 types of solutions when you're solving quadratics. The quadratic can cross the x-axis twice, and this can face up or down. I'm just going to face it up right now. So since it crossed twice, this has 2 solutions. Like the answer might be, on this one, the answer is here when x equals 1, and also here when x equals 2. So you could write either 1, comma 2. Don't put parentheses around it because then it will look like an ordered pair. Or some people, I've seen them write them as ordered pairs. They write 1, 0, and 2, 0. You can write it either way, but don't mix those two. They'll take it either way on the final. So another type of solution is where it just touches down once. And I'll make it upside down this time. So let's say it just barely touches the axes right there. Okay? That one, this one has 1 solution. And you can either say x equals -2, or you can say -2, the point -2, 0. One or the other. You don't have to say both. Okay? And then the third type is when you don't have a solution. So I'm going to make it facing up. When a quadratic is above or below the x-axis and it reverses and the lowest point never touches it, that means that it never touches that axis. So that means there's no solution. And I'll show you what those look like when you're solving algebraically. How do you know it's a no solution if there is no solution? So those are the 3 types of solutions that you'll come across. So solving symbolically or algebraically without graphing it, remember you start it, a lot of times they start with the function. So the function is x squared minus 6x plus 8. If it's not in this form, make sure you put it in that form. The next thing you want to do is set it equal to 0. So x squared minus 6x plus 8 equals 0. And now you want to think about all that stuff that you learned previously in this class, how to factor. So when you look at this left side, do you factor by quadratic factoring? Do you pull out a GCF? Do you use your square roots, your radicals? What do you do? So right now, if I look at this, because it has an x squared, and I can see that if I was looking to factor it, I want to look to see, because there's no greatest common factor I can pull out, I want to also look, could I factor it then? Is there something that multiplies to 8 and adds to -6? Well, sure. -2 and -4. So I can say x minus 2, x minus 4. So now that I've set that equal to 0, I want to find out what makes this 0 and what makes this 0. So I can set this one equal to 0, and you can see that without having to show work on this part, but some of them won't be so clear. And so if you can't see what makes it 0, then solve it for 0. I can solve this one by setting it equal to 0. Remember, I'm trying to find where the line crosses the x-axis. The reason I'm setting it equal to 0 is I want to know what happens, what is the x when the y is 0. Okay, so that must mean that it crosses at the point 2, 0, and it crosses again at the point 4, 0. So if I was to graph it, then it faces up, and you'll learn why it faces up. The reason it faces up, I can tell you right now, is that the leading coefficient where the A is a positive. So it faces up, and it crosses axes. So it looks like this. And I'm not sure how far down it goes, and you'll learn how to find that out later, but it crosses here and here. Okay, so my solution, you can either say your solution is these points, or you can say the solution is 2 and 4. Don't put the 2 and 4 like this, because that means it's crossing at 2, 4, and 2, 4 is a point floating out here, and that's not crossing the x-axis. So just make sure that you don't put those two numbers as ordered pairs. So now let's look at solving it graphically. So if you're going to solve it graphically, here's the equation again. So I had x squared, oops, let's try this again. I had x squared minus 6x plus 8 equals 0. And so if I was asked to solve it graphically, which you're going to have to do both, then I've got to have some points to be able to graph it. So I know I'm going to have some x's and y's. A good point to find would be that vertex, and you found that vertex in previous sections. So that vertex, if you want to find the x the x value at the vertex, it's negative b over 2a. So remember, the b was right here, and the a was right here, and that's a 1. So I would have x equals negative 6 over 2 times 1. And that's going to equal 6 over 2, which equals 3. So I know the x value is 3. And so I can put a 3 here, but I don't know the y. So in order to find the y, I have to plug it back into the original equation. So the original equation was x squared, so I'm going to take 3 squared minus 6 times 3. All I'm doing is putting a 3 in everywhere where the x is on that equation, and I'm solving it. So 3 squared is 9 minus 18 plus 8. So that's negative 9 plus 8, that's negative 1. So when x is 3, y is negative 1. So I can go over to my graph and go 1, 2, 3, down 1. I know that, oops, I know that that point is going to be the vertex. If I know that that point is a vertex, I also know that that's a line of symmetry too, and let me do it in a highlighter. So here's the line of symmetry. So the axis of symmetry, they're going to ask you that too, is x equals 3, because the line of symmetry runs through where the x is 3. So now I know both of those. I need some more points. So one of the points I can put in is 0. So let's say I put 0 in for x. Well, if 0 is in there for x, let me erase this so I have room. If I put 0 in for x, then I can run it through the equation. 0 squared minus 6 times 0 plus 8. So that's going to make 8. So I can go to 0 and 8. 3, 4, 5, 6, 7. Oops, and I don't really have enough room, but I'll put it up there. So I know that's a point. So I can and I'm just randomly picking numbers. What if I want to pick 2? I want to know what happens when x is 2. So I get 2 squared minus 6 times 2 plus 8. So that's 4 minus 12 plus 8. And that's negative 8 plus 8. So the 2 and 0, that's right there. So now that I know some points on the left-hand side, remember that the axis of symmetry is the mirror. So if I have this point right here and it's one step away from the axis of symmetry, I know that there's another one right here and I don't even have to make a table for it. Same with this one. If I know this is 3 jumps away from the axis of symmetry, I know that the other point is going to be 3 jumps away. And now I can graph it. Oh, don't graph it with just 3 points. Try to make 4 or 5, and you do need arrows on your graph or they take points away from you on the final. So that's how I would graph that quadratic equation. Take a look at the form that A was positive, and so it's facing up. So here's a different type of problem. So here's another one. So I would set it equal to 0 again. The reason why you're doing that is because you want to know where the parabola hits the x-axis, and where it hits x, the y is 0. So it's just like putting it equal to y and then replacing y with a 0. So I'm going to go ahead and solve it symbolically, show you what that looks like, and then solve it graphically too. So symbolically would be setting it equal to 0 and factoring it. So you can see that the left-hand side has 2x squared plus 1. You always want to look to see if you can pull out a GCF, a greatest common factor. There's nothing in common between 2x squared and 1, so you can't do that. The other thing that you want to do is look at it and see if you can factor it into like binomials like we did the last time. You can't do that, but you can see that I have this squared here, and I could isolate that since there isn't another x, so there's 0 for the b. Then I can go ahead and pull my 1 over, get 2x squared, and we did this a couple sections ago. Divide by 2 to isolate the squared, isolate the exponent, so that then you can use the square root. So I can square both sides. Remember that the square root and squared cancel each other out, and I get x on the left, and I get a positive and a negative, square root negative 1/2. Well, there's no way that you can have a negative inside the radical. You can try that on your calculator and it'll tell you error. And so this one is a no solution. So what that means is that if I graph it, it better not cross that x-axis if I'm correct about solving it symbolically. So let's go ahead and graph it to check the solution. On the final, you'll be asked to graph some, and you'll be asked to solve them some symbolically. So you got to know how to do both of them. So first thing I want to do is find my vertex. So the vertex was negative b over 2a. That gives me the x value, right? So since it's 2x squared and there's no b squared or bx like number x, let me explain this up here. This will be easier. Ax squared plus bx plus c. Remember how a quadratic has to be in that form? And the b is next to the x. So since there is no just a single x by itself in the equation, then I know that the b is 0. So I can place 0 in there. There's no such thing as negative 0, so I'll just put a 0. And 2 times 2, because the a is 2. And I get 0. So I'm going to start a table here. I know that my x value is 0 at the vertex. If I want to find my y, I have to plug it back in. I can plug it back into the 2x squared plus 1, and I will get 2 times 0 squared plus 1. And you can see that the c then becomes your y value. And I'm going to erase this, whoops, so that I have room to graph. So when my x is 0, my y is 1. So that's right there. Okay, so that's my vertex. It is facing up. I know it's facing up because this is positive. So I'm going to pull a few more points out of there just to make sure. So I'm going to put 1 in there. If x is 1, then I get 2 times 1 squared plus 1. So that's 2 times 1 is 2, plus 1 is 3. So over 1, up 3. And remember that this is my line of symmetry, so there must be a point over here too. And always take one more point before you draw, so maybe I'll plug in 2, and I'm going to get 2 squared is 4, times 2 is 8, plus 1 is 9, so 2 and 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then over 2. So my parabola looks like this. Whoops, that wasn't drawn very good. The arrows at the end, I can see that it does not touch the x-axis, so that's true, there is no solution. My axes of symmetry, I don't want you to forget how to do that, because you will be required to do that too. My axis of symmetry ends up being x equals 0, because it ends up centering on the 0, on the y-axis. So here's a third one. On this one, I can see that I do have an x and I have an x squared, so that means I'm going to have to set it equal to 0 and it should factor somehow. So I'm going to go ahead and pull my 4x over. I'm going to get 0 on the right hand side. On the left, I'm going to go ahead and put it in that form of a quadratic, that ax squared plus bx plus c. Then I can look at that and say, okay, well, I must be looking for binomials because I have an x squared and an x and there's not a greatest common factor to pull out. So I'm looking for something that multiplies to 4 and adds to negative 4. So what times what makes 4? Positive 4, but adds to negative 4. That's negative 2 and negative 2. So x minus 2 and x minus 2, set them equal to 0. I'm going to take each of these and set them equal to 0 because I want to know what is the x when y is 0. And the other one is exactly alike, so that means I'm just going to get x equals 2 for that one too. So that means there's one solution, and it's x equals 2. Or you can write it in ordered pairs, 2, 0. Okay, I'm going to graph that just to make sure, and because sometimes you'll be asked to graph instead of solving symbolically. So I'm going to find my vertex. Let me erase this so I have room. My vertex is negative b over 2a. So look down in through here, and I can see that my b is a negative 4. So I have x equals negative 4 over 2 times a, and my a is 1. So I get 4 over 2, which is 2. So if I make my table, x is 2. I can plug 2 into the original, or you can plug it into the original equation, or you can plug it into the one right here. And I get 2 squared minus 4 times 2 plus 4. Squared is 4. So that's 0. So I go over 2 and 0. And notice that my vertex is on the line, so I don't even have to continue graphing. It's not going to matter if it's facing up or down. My vertex is on the line. I know my solution is x equals negative 2. This one will be facing up if I was to graph it. The reason I know is because the a is positive. If the a is negative, it will face down. So here's 3 more to try. You could pause it, try these 3, and then come back. So I'm going to solve the first one first. I'm just going to do them symbolically. I'm not going to graph them. Okay, so because this one has an x squared and an x, I'm going to set it all equal to 0 and try to factor it. So I'm looking for something that multiplies to negative 5 and adds to 4. So what multiplies to negative 5 is negative, or positive 5 and negative 1. That way it adds to 4, positive 4, and it multiplies to negative 5. You want to make sure you have those signs in the right spot. So if I solve this one, I get x equals 5. If I solve this one, I get x equals positive 1. And so my solution, there's 2 solutions. And my solutions are right there. I can also write them just as 5, 1, but just don't put parentheses around. Or I could write it as 5 and 0 and 1 and 0, the 2 points at which it crosses. Okay, next problem. I'm just trying to give you some practice problems. I can see that this is x squared and there's not an x in there, and so I can go ahead and isolate my exponent and use my radical to solve. And so my exponent's already isolated, it's on one side, so I don't have to move anything. I can go ahead and square both sides, and I get x on this side. Over here, don't forget, you get a positive and negative square root of 4. Well, the square root of 4 is 2, so I get plus and minus 2. So this one has two solutions. And my solutions are x equals 2 and x equals negative 2. Okay, and then the third one, I can see that there is not an x. So again, I'm going to go ahead and pull the 2 over to isolate the exponent and use that same strategy that I used on the last one. So I'm going to use my radical. I'm going to get x on the left side. I'm going to get plus or minus square root of negative 2. I can't take the square root of a negative number, so this one is no solution. So one more type of problem, probably the most important ones because they're the story problems. They're the ones that relate to real life of why you would ever use this solving of a parabola. One of the main problems that you see over and over is when they model a falling object. And so a toy falls from a window of 30 feet high. How long will it take to hit the ground? And they'll give you an equation. Okay, so usually if you're dealing with things that are falling, your equation will have a negative 16t squared in it. That comes from gravity. Okay, and then it's 30 feet high, so that's where the 30 comes from. So they'll ask you to solve that. So it's just a matter of, I'm trying to find how long. So I'm looking to solve for time. Well, time is just like having the x, right? Just like having the x squared. So relate this to f of x equals 30 minus 16x squared. That looks the same, it's just that there's a f of x where the d of t is, and there's an x squared where the t squared is. So the d of t just means distance. The function will give you the distance in respect to time. And so you're just going to go ahead and plug it in. So you have d of t equals, so what I would probably do is move, so we'll set it equal to 0. So 30 minus 16 t squared equals 0. And then you can see that there's a t squared, but there's not a t. So that means you should be able to use your square root or your radical to solve. And so in order to use the radical to solve, you need to isolate the radical. So I'm going to move the 30 over to the right. That leaves me with negative 16 t squared equals negative 30. I'm going to divide by negative 16 to isolate the exponent so that I can use the radical. So I get t squared equals a positive 30 over 16. I'm going to square both sides and continue over here. And I get t equals positive and negative square root of 30 over 16. And so at this point in story problems that don't come out as a perfect square, you can go ahead and use your calculator to solve this. At that point, you can plug that into your calculator. So I would get t is, it'll come out to be about positive or negative 1.4. Well, time can't be negative, so then you know that that's not part of the solution. Because this is a story problem, then some of the solution doesn't make sense. Okay, so then I know that it takes about 1.4 seconds to hit the ground. So if you were to model this, what's happening is it's going like this. Okay, and this is one Don't ignore the graph paper, but this would be like 1.4. So the ball is coming out of the window or the toy, and it's hitting the ground here. The reason why you don't have a negative is there's no such thing in the story problem as the ball coming off the floor, jumping into the window, and then coming back out.